So we're on video 4 for MAPP 4, and we want to kind of analyze what we're looking at right now. We have a live trace of the subs. The subs are listening to the subs, and the mains are muted, but we've got a stored mains trace we're looking at there. And you can see they do cross over nicely at 80 hertz. If I zoom in here, we can see that 80 hertz is indeed our crossover frequency of equal level. You can see that they're not exactly in phase. If I zoom in here, hitting the magnifying glass and going to the low frequencies and try to find our crossover at 80 hertz, you can see they're about that far away from each other, which is about 120 degrees. It's 60 for an increment there. 120 degrees, if you remember your phase wheel, is neither loss nor gain. It's 0 dB summation, so we're not getting any benefits here. We'll get 6 dB if we can slide this guy in. And over here in the impulse response, this is really where it's interesting. And I think this is interesting because on SMART, you can't see low frequencies on the impulse response because its frequency resolution is linear and it mostly looks at highs. And here you can see that you can see the lows. The blue is the sub, and those are the lows. The red is the line arrays. And you can see they arrive here, but the subs are kind of spread out. So what's really going on here? There's some interesting stuff here. I find this very fascinating. If you look at the model itself, let's check out top-down view. This is the measurement mic here. You can see you're actually closer to the subs than the mains. And traditionally when I've taught this class, I would say, okay, well, we better delay the subs to the mains. Like they get the delay and so that they can wait for those to arrive there. I've been wrong, and I didn't really know I was wrong until I figured this out, that you can see that the sub does indeed start before the mains. But when you look at this impulse here and you start thinking about what it really is, and this is the confusing part, this is the spreading, the elongation of the low frequency energy over time. And the mains don't seem to have as much, and that just means they're tighter, they're more phase accurate, or what's going on here, and maybe it's filters, but it's probably the porting on the loudspeakers that really kind of create all this group delay. And the group delay, of course, delays the low frequencies more than the highs with loudspeakers. That's why the phase trace tilts upward in the lows. And so if we could actually analyze what's going on here, this is in the blue, that is, not the red. I can hide the red for a moment. These are the highest frequencies of the sub, say 200 hertz or something. And as we go down in frequency, the lower frequencies are delayed more in time. And so the real question in my mind is where is 80 hertz in all this? Because 80 hertz is the frequency that we want to align with this red line. This red impulse, of course, is the mains. And so where in this blue squiggly line of the subs is 80 hertz? Because that's what you want to align with red. Now, you can't tell here. You can't use the IFFT, the impulse response, and you certainly can't do it in SMART because SMART won't even show you this blue squiggly line. It just won't even show up. So we can't use it. We have to use the phase trace. And over the phase trace, at this point in the semester, you should be familiar with how to read this. We need to align the angle and value of this phase with that. So we need to add some delay. The question is, who do we add delay to? This is the big question. Are we going to delay the blue, i.e. the subs, because they arrive earlier in time to line up with the red, or are we going to delay the red to move it this way in time so it's going to line up with wherever 80 hertz is? Now, my money is on moving the mains, not the subs. So let's mute the subs. Now, here's the bummer part. As I open up these mains, I'm going to have to put in, what basically going to do is add a millisecond of delay time. We're going to look at the stored substrace. Okay, there's the stored substrace, and we're going to time align the mains live. When I start typing in delay times here, 1 millisecond at a time, let's open up the mains here. If I open these all up, do a prediction, and go sorry, live trace is hidden. There it is. I'm going to have to add a millisecond to each one of these processors, all 12, every time I predict. And add a millisecond and go, I need to add another millisecond and do it again and do it again. It's going to be extremely slow. So we need to find a workaround to make this much more efficient. First thing we can do is mute the right array. The microphone is equidistant from the left and right, so we can just do this with one array. The second thing we can do is take all 10 of these boxes that are spread across those 6 drive lines and put them all on drive line 1. So you only have to mess with one channel. So this is pretty easy to do. We just go to object settings. We need to make sure we pick our loudspeakers. So I'm going to pick my loudspeaker icon and I'm going to pick the left mains. And last week in your assignment, you should have dispersed those 10 boxes of the array across 6 drive lines. You're going to undo that work now. At the very end of this assignment, you'll bring it back. But essentially, you're taking all 10 boxes of the left array and putting them on one single output. So this will make it unnecessary for us to do delay across multiple channels. So here we go, back to express settings. Now, essentially, these guys are all useless, but that guy has all 10. So there you go. So with that done, folks, we are ready to start adding milliseconds. Now, I want to look at the instructions, make sure I haven't missed any important things to talk about. I've talked about all this. I've done all this, and we've just did that. So I believe we're ready to do the cool stuff. And that's do the phase alignment. So I'm going to add some delay here. Let's add 1 millisecond delay. Watch the blue trace move. And it's not quite in alignment. I think it got better, though. Let's try 2. Yep, it's definitely getting better. It's coming into alignment. The angle is starting to shape correctly. And so if this is 80 hertz here, you could argue that that's pretty much right on. Right? Would you say that that's pretty close? Let's go 1 millisecond too far. Yeah, it's kind of losing it. Perhaps it's right in the middle. This is 3.5 milliseconds. I like that. I'm going to stick with 3 just because I don't think it matters very much. So 3 milliseconds brought these guys into time alignment. Look what happened over here. Now we kind of know where 80 hertz actually is in the distribution of time. This means that a lot of this is really, really low stuff. You know, this is the low end of the curve. Perhaps it's down in here as far as energy. But anyway, that's where we needed to be all along. Now, just a side note, very, very important side note. I just did all of this on my system here in demonstration. This is the Leopard system. This is the 750 LFCs and the Leopard. This is not the Gracie PA that's in your assignment. Your PA is going to have slightly different phase response because it's an older model and it was designed at a different time with different approach. I cannot guarantee you that it's not the subs that need to be delayed, not the mains. Like, it may be the opposite. And if that were the case, the opposite approach of doing this, if you ran into that situation where you had to delay the subs instead, the live trace would not look at the mains. The live trace would look at the subs, and I would only do the front sub. So you only have to do delay time on one of the sub channels, and you would look at the stored mains trace. So you do stored mains, and you would do live sub, and you would delay the live sub until you got them lined up. All right, just the opposite approach.